Assalamu alaikum guys. We are starting chapter 7, lesson 1. I know the last test that you all took was chapter 5. We're skipping chapter 6. Inshallah, by the end of the year, I doubt it, but if we can, we will come back to chapter 6. Chapter 7 is just much more important than chapter 6 in Algebra 1. That's why I'm going into chapter 7. So we're starting with polynomials. Now, you see an expression written right here, and that is what a polynomial is. So we have 3x to the fourth plus 2x to the third plus 6x minus 5. Now, the polynomial itself has a lot of labels to it that you need to understand when you're being asked or certain terms are being used. So the first thing I want you to notice is that 3. The 3 is the leading coefficient. The leading coefficient basically is the numerical value that is in front of the variable, and it's the leading term, number 1. And another thing is only if the polynomial is written in standard form. Standard form basically means in order based on power, and of course that's the degree. The 4 is the degree of this polynomial. And then also the last thing is the constant term. Constant term in this case would be a negative 5. There is a minus in front of the 5, so it's considered a negative 5. Constant term never has a variable with it. It stands alone. It does not change in value. It just gets applied as it is. So in this case, we have 1, 2, 3, 4 terms to the polynomial. Okay? So a term basically means you might have a leading coefficient. You might not have a leading coefficient, but you will have at least one variable. And then how do you know the difference between terms? If you have a plus or a minus in between. So 1, 2, 3, 4 terms again, okay? Now, you're gonna have to classify polynomials. So when there is only one term, it is called a monomial. When you have 2 terms, it's called a binomial. When it's 3 terms, it's called a trinomial. And the minute you get to 4 or more terms, we're not gonna cut it up into whether it's a quadnomial, quintinomial, and so on and so forth. After that, it's just called a polynomial, okay? So the first thing you're going to do is you're going to find the degree of each monomial. So you're already being told that all of them are going to be monomials, okay? So let's say, for example, we have 6w to the fourth. They're asking you to find the degree. So go to the exponent. It is raised to the fourth. So this would be a 4th degree. Okay? Now, let's try another one. What about, even if you have, guys, decimals, the degree always comes from the exponent itself that is with the term. In this case, and what I mean by exponent, I mean the exponent on the variable, okay? So in this case, this is going to be called a 2nd degree. So the term is a 2nd degree term, okay? What about when we have 10x squared y to the 4th? Now be careful with these, because in these, you have to consider the exponent of both variables. So in this case, you would take your 2 and your 4, because the whole thing is a monomial, okay? So you would take your 2 plus your 4. The power of the whole term is 6. So in this case, this would be a 6th degree monomial, okay? So just remember, however many variables you have in that one term, add up all the exponents. What if you have negative 2ab c squared? Again, you might not see the power, but there's a 1st degree, another 1st degree, and then you add up all those exponents. 1 plus 1 plus 2 is 4, so this would be a 4th degree. Okay? And what about this one? What if I just have the variable p? What's the exponent on that? The invisible one. So this is a first degree. Okay? So the last example in this section, this one I wish I had you all in class, because I would ask, what is the degree of this monomial? Now, I know that a lot of y'all are going to say most likely 1. Well, the 1, the invisible one, is on the 25. But remember what I said at the beginning. When you determine the degree, you're looking for the variable, right? You're taking the exponent on each single variable, whether it's just standing there alone with a variable, or whether you have 2 variables or 3 variables and you're adding them up. But what happens when you don't have a variable? You have to assume that there's a variable there. Now, to think about it, what would be the variable here, or the exponent on a variable here, that would not change the value of 25? So let's say, for example, I have a variable of x. I know that it doesn't have a variable, but what would the power on that x have to be in order for it not to change the value of 25? And I wish I had you all, honestly, but the power to that x in this case would be 0. And remember, what is anything to the power of 0? 1. So in this case, 25 times 1 still equals 25, and it did not change in value, right? So in this case, when you have a numerical value and you're being asked what's the degree, assume that there's a variable there and that the power is 0. So this would be a 0 degree. Okay? So you will have questions like that, and just pay attention to the exponents. If it's only a numerical value, you're to assume that there's supposed to be a variable sitting there, and just by default, right, anything to the power of 0 always equals 1, as long as you don't change the value of the term that you have been given. So the next section of this lesson is going to be to simplify. Simplify basically means that you need to combine like terms, if possible. Now, let me write the first ones. All right, let's say that we have, let's see, negative 9x to the 4th plus 12x to the 4th, okay? Now, when you simplify, you need to make sure that all the variables have the exact same power. You cannot combine an x to the 4th with an x squared, let's say. Like terms means they're exactly the same. The only different thing might be is the leading coefficient on each term, okay? So right here we have a negative 9x to the 4th plus 12x to the 4th. Look at your variables, both are raised to the 4th power. So now I can go ahead and add or subtract the coefficients. So negative 9 plus 12 is a 3, right? And then just bring the variable down. Do not add exponents, guys, okay? You're not multiplying. Remember that, because one of the things that kids forget is that they're used to the previous lesson where we were multiplying the same base and they add exponents. Here, you're just combining the terms. You're not multiplying them. You're not dividing them. You're not raising them to another power. You're just simplifying them and adding them up, okay? So in this case, 3x to the 4th. All right, what if I have 3a squared b plus 7a squared b? First thing you need to check, look at your variables. A squared, b to the 1st, b to the 1st. The minute you check and the variables are the same, then you can go ahead and combine. So in this case, 3 plus 7 is 10, and then it's a squared and b, and that's the answer. Okay, let's try another one. What if I have 16 j k to the 3rd, and then I have negative 9 jk to the 3rd? check your variables, j to the first, k to the third, k to the third, then I can go ahead and combine. So 16 minus 9, you should get 7jk cubed. 7jk cubed, or to the third. Okay? I don't know if you can see that very clearly, but it's supposed to be to the third. Now, how about this one? And this is the last example on this one. So you have 4x squared, 8b cubed, and I didn't mean to write a b. I meant to write a y. And then I have so I have 4x squared y cubed plus 3x cubed y squared. And like I said, check the variables, guys. I have x squared, x cubed. Automatically, I can tell you already we cannot combine. And even the y cubed, y squared. So when you have a problem like this, you write one of two things: simplified, in other words, you cannot combine, or you write cannot combine. All right? So the answer here, if you had this on an assignment or on a test or a quiz, you would put simplified or cannot combine. And the whole point, guys, is go ahead and look at your variables. Make sure that down to the exponents, they're exactly the same, and you can, whether you can combine or not, make that judgment. So the next part of the lesson, guys, and we're gonna do this lesson over 2 days, just not to put pressure on you all. And since we don't have EOC, we have extra time to work on this chapter. So you're going to rewrite the polynomial, and you're going to rewrite it in standard form. Now, what does standard form mean? In standard form basically means writing the polynomial based on power in descending power. All right? And then you're going to classify. In other words, you're going to name it. You're going to name it based on degree and number of terms. Okay, so those are your instructions. You are to rewrite it, and then you need to classify. Classify it means give it the name that it is, and based on degree, you're going to look at the degree of the leading term, and then you're going to base it on the number of terms as well. So let's say that we have 7x minus 5x squared, and then plus 6. All right. Notice that my 5x squared is in the middle, and that is the strongest term because it has the highest degree. This is not standard form. So the properly written way should be negative. Remember, there's a minus 5x, so rewriting it would be negative 5x squared. The next term that has a power to it would be the x to the first, right? So this term is positive, plus 7x, and then my constant would be just plus 6, okay? So here it is, 5x squared plus 7x plus 6. So this is the first answer. The next answer is classified. Give it its name. What is the name to this? We're going to do it by degree and then number of terms. The degree is a square, or it's a second degree. Now, in algebra, when you're dealing with polynomials, we're not going to call it a second degree polynomial or trinomial or monomial. We're going to call it a quadratic. Quadratic think about it, 1, 2, 3 terms. So this is a quadratic trinomial. All right? And if it would be to the third power, then it would be a cubic term. All right? Now, let's try another one. How about if we have 3a squared plus 4a minus 7a plus 6a squared. Now notice that you have terms. You have 3a squared plus 6a squared, okay? And then these two terms are alike. Not only that, you've also got these middle terms, all right? These middle terms that can be combined. So before you rewrite, guys, or before you classify as well, go ahead and combine any like terms, simplify it as much as possible, then classify it. So in this case, 3a squared plus 6a squared is 9a squared. Then you have 4a minus 7a, it's negative 3a. All right, don't forget that this was also part of the answer on the previous question. So here is our first answer. That's the rewritten. It's in standard form. My a to the power of 2 is first, and then a to the power of 1 in descending order. Now remember that I said anything to the power of 2 is called a quadratic, and then we have how many terms? 2 terms. All right, so this would be a quadratic binomial. All right, quadratic binomial. So we've got 3 more examples on this, because I want you exposed to every single type of question that you might get in this section, so you can be clear on it and not have a doubt as to how you label these things. What if I have 16 minus 7y to the third? Okay? Now, this has only 2 terms, so we already know it's a binomial. We cannot combine anything because 16 does not have a variable to it. So standard form would be 7y cubed, and don't forget that negative, and then plus 16. All right, so here is my standard form. And then remember, this is a cube, or to the third, right? So this would be called a cubic binomial. A cubic binomial. All right? Now, how about this one? 7a to the 5th plus 3a to the 4th minus 2a cubed plus 15. All right? Is there anything that I can combine? Obviously, all the exponents are different. I cannot combine anything. Then I need to make sure, is it written in standard form? It's to the 5th, to the 4th, to the 3rd, and it's already in standard form. So in this case, just rewrite it as is. I'm not going to take the time. I want to save the board space, but you would just rewrite it as is. It's already simplified. And then what's the degree here? The highest degree, which is in the leading term, is the 5th power, right? So how many terms do I have? 1, 2, 3, 4. Remember that we said the minute you have 4 or more, it's called a polynomial. So this is going to be called a 5th degree polynomial. Okay, it's that easy. Now here we go with the next one. 14x third minus 9x third. Let me write that to be clearly. So we have 2 terms. Both of them have x's to the power of 3. So can we combine these terms? Absolutely. So when you take 14 minus 9, it should give you 5. And then don't forget x to the 3rd. So there's that answer, okay? And then I need to name it. So it's 1 term, so we know it's a monomial. The power is 3, so it's a cubic binomial. Monomial. All right, so that is it basically, guys, for the first half. The next half of the lesson is going to be, combining larger terms and expressions and then applying it to real world issues, believe it or not. You might not see it in everyday life, but obviously some mathematicians do use it for statistics, this type of math. And inshallah, you found the lecture easy. I'm going to be trying to take it as slow as possible, but at the same time not watering it down for you all, because I do want you at your best, especially if you're going to be taking geometry over the summer. So the previous chapter was more important for geometry, but this one is more important for Algebra 2. So we'll see you in class, inshallah, and take